Alright guys, in this tutorial we're going to be working on some practice problems that are related to the dimension analysis. So just to start out with, let's focus on this first problem that's asking to convert 120 calories to a kilojoule. So both calorie and the joules are actually the units for energy. And before you do anything, you want to make sure you know the relation between the calories and the joules. And as a side note, this calorie, which has an a lowercase c, so 1 calorie with a lowercase c is equal to 4.184 joules. Uh, the calorie with lowercase c is also called a chemistry calorie. You could also see a calorie with an uppercase c, that's going to be something like this, and that's actually equal to 1,000 lowercase 1,000 calories with a lowercase c. And this calorie with an uppercase c is also called a food calorie. So when you see the amount of energy in food packets, they are talking about these food calories that has an uppercase c. Okay, and in addition to that, I could also write that down as 1 cal, because remember, k is just a kilo. And then if I want to convert the joules to kilojoules and vice versa, remember 1 kilojoule would be just equal to 1,000 joules. So if you know some of these conversion factors, you should be able to do this problem. So our job here is to figure out how we're gonna convert this this calorie with the lowercase c into the kilojoules. So what we can plan out, we can go ahead and convert this calorie to the joules first, and then convert the joules to the kilojoules. Okay, so when we're converting this calorie to the joules, we want to be using the very first conversion factor that I have written up there, and then so that's going to be 1 calorie equals to 4.184 joules. And when we're converting the joules to kilojoules, we want to be using 1 kilojoule equals to 1,000 joules. So those are the two conversion factors you want to be using here to convert this 120 calories to kilojoules. So your first job is always to figure out, always to plan out how you're going to go from one unit to another unit, and also what conversion factors you're going to be using. Once you know how you're going to go from point A to point B and what conversion factors you're going to be using, it's all about setting it out. So when you set it out, you always write down what's given to you in the beginning. So it's going to be 120 calories. And then in the first step, I need to convert this calorie to the joules. So I need to put the joules on the numerator, and I need to put the calories on the denominators, and I want to do that so the calories will cancel out and that leave you with the joules. So keep in mind, whatever unit you're trying to find out goes on the top, and whatever unit you're trying to get rid of, it goes on the bottom. And after setting up the units, it's all about putting in the numbers now. So the numbers you have with the joules and the calorie, we got 1 with the calorie and we got 4.184 with the joules. So you got to go ahead and write those numbers down here. So 1 here and 4.184 joules here. Okay, so then you have the joules now, and in the second conversion factor, you want to go ahead and calculate the kilojoules. So since you're trying to calculate the kilojoules, we need to put the kilojoules on the top, and we need to get rid of the joules. So I would put the joules on the bottom here. All right, so make sure you set up your units correctly. When you do so, your joules will cancel out, and then it's all about putting in the numbers. So remember, 1 goes with the kilojoules, and then 1,000 goes with the joules. So I would put in 1 here and 1,000 with the joules. And that's pretty much it. So when you set up all your units correctly, every single unit will cancel out except the one you're looking for. So in this case, calories cancels out, joules cancels out, and you're looking for the kilojoules, and that's what you have at the end of the day. So, well, when you do this math here, so we got just multiply 120 by 4.184. And obviously, if you can just do the math, some of the math in your mind, but feel free to use a calculator there. So this comes out to be 0.50208, and make sure you keep track of your sig figs. And how many sig figs we have in 120? So since there is no decimal in 120, so that's the number that's given to you in the beginning. If you're using any numbers in the conversion factors, don't focus on those to get your sig figs. It's always going to be the number that's given you in the original question. So 120 actually has two significant figures, so make sure you don't have more than two sig figs in this answer. So the two sig figs would be 5 and 0 here. So whether the 0 stays 0 or becomes 1 depends on the very next number that you're dropping, which is 2. So since this is less than 5, you leave the 0 as 0. So your final answer is going to be 0.50 kilojoules here. Okay, so that's how you do this, the conversion of calories to the kilojoules. Let's look at another problem. Here we're trying to convert degrees Fahrenheit to the Kelvin. So there are two equations you want to be aware of that are relate different scales of temperature. So we got the temperature in Fahrenheit is equal to 1.8 the temperature in Celsius plus 32. And then we have the temperature in Kelvin equals to temperature in Celsius plus 273.15. So first of all, we are given the Fahrenheit scale and we're trying to calculate the Kelvin scale. So maybe you can use the first equation here. So use the first equation to calculate the temperature in Celsius, and then use the second equation to find the temperature in the Kelvin scale. So let me just go ahead and use the first equation. So when I use this first equation, it's going to be 77 equals to 1.8 the temperature in Celsius plus 32. Okay, so you can subtract 32 on both sides, and that gives you 1.8 the temperature in Celsius, and we have 77 minus 32. That's going to be 45, and then you can divide both sides by 1.8. So when you divide both sides by 1.8, the temperature in Celsius comes out to be okay, so we got 25 here, 25 degrees Celsius. Okay, so once you have the temperature in Celsius, you can use the second equation to find the temperature in the Kelvin scale. So let's go ahead and plug that in there. So the temperature in the Kelvin scale is going to be the temperature in Celsius, which is 25 plus 273.15. So when you do this math, it's going to be 298.15 Kelvin. Now, make sure you keep track of your sig figs there. So in this particular case, we have 77 that technically have two sig figs with no decimal place whatsoever. And when you're looking at the type of calculations you have done, it's mainly additions. Like you added you subtracted 32 from the 77, and then in the second equation you added 273. So you're going to be using the addition and subtraction rule in this particular calculation. So if you recall, the addition and subtraction rule talks about the least number of decimal places in your answer. So when I look at my number that's given in the question, which is 77, that does not have any decimal place. So since it does not have any decimal place, your answer should not have any decimal place either. So at the end of the day, when I round this up, it's just going to be 298 Kelvin. So that's going to be the temperature in the Kelvin scale at the end of the day. All right, so you could be given the temperature in the Fahrenheit and asked to calculate the temperature in Celsius and vice versa, or you could be given the temperature in Kelvin and asked to calculate the temperature in Celsius and vice versa. So you're going to be using those two equations to go back and forth between those three temperature scales. So if you know one, if you know to do this type of problem, it should not be an issue to do other types of temperature problems. All right, it's extremely important to understand the temperature conversions because you never use Fahrenheit in the calculations. You only use Celsius few times here and there throughout the semester, but for the most part, it's the Kelvin scale that's going to be used in the calculations. All right, okay, let's look at another one here. So we have this 5.70 liters volume, and we have to convert it to the inches cubed. Okay, so um, we want to connect the liters with the inches. And obviously, if you go ahead and Google the conversion factor between the liters and the inches, you may see a number, but we want to use the one you actually know already. And think about the relation between the inches and the centimeters, and the relation between the centimeters cubed and the milliliters, and then the milliliters into the liters. So for example, if I have liters to begin with, the first thing I want to do here is convert it to milliliters, okay? And then from the milliliters, I want to go ahead and convert it to centimeters cubed. And then from the centimeters cubed, I can go ahead and convert it to the inches cubed. Okay, so when we're going from liters to milliliters, remember milli is just a prefix, which is 10 to the minus 3. So I can write down as 1 milliliter is going to be equal to 10 to the minus 3 liters. That's one way of writing it. And if you want to go ahead and write it like 1 liters equals 1,000 milliliters, that's completely okay as well. It's the same thing writing either one of those ways. Once you have your liters converted to the milliliters, you want to go ahead and convert it to the centimeters cubed. And when you're converting those to the centimeters cubed, remember this conversion factor. By definition, 1 milliliters is equal to 1 centimeters cubed. Okay? And then when you're going from the centimeters to the inches, I would have 1 inch is equal to 2.54 centimeters by definition. So those are the conversion factors we're going to be using to convert this volume in the liters into the inches cubed. Okay, so like I said, once you know the plan and once you know what type of conversion factors you will be using, go ahead and set it out. So we have starting out with 5.70 liters, and then in the first step, we're trying to go to milliliters. So your milliliters will go on the top, and we're trying to get rid of liters. We'll get the liters on the denominator there. And then go ahead and put in the numbers there. So we have 1 with the liters and 1,000 with the milliliters. So I use the second conversion factor here, and you can very well use the first one as well. It will still give you the same answer. So in the first step here, you have the liters cancels out. Now the milliliters needs to be converted to the centimeters cubed according to our plan. So when I set my second one here, we need to have the centimeters cubed on the top, and we want to have milliliters on the bottom here. And then go ahead and plug in the numbers. So 1 goes with the milliliters and 1 goes with the centimeters cubed. By doing so, the milliliters cancels out. And then finally, we want to go ahead and convert the centimeters into the inches cubed. And the conversion factor I know here is going to be, since we're trying to find the inches, so I'll put the inches on the top. And we're trying to get rid of the centimeters, we'll put that in the denominator. So I know 1 inch is going to be 2.54 centimeters. Okay, well, there is one more thing you have to be really careful with. So remember, this is a centimeters cubed, and the conversion factor we have here, between the inches and the centimeters is just in one dimension. So we want to make sure we have centimeters cubed and the inches cubed here. So to get those cubed, you have to cube this whole equality, including these numbers, the 1 and the 2.54. Obviously, when you cube 1, it still stays 1, but when you're cubing 2.54, it will change to a different number. So make sure to cube this whole equality or the conversion factor. So when you do that, this becomes centimeters cubed on the denominator, so that will cancel out with this, and it will leave out only inches cubed here. So we'll have inches cubed to be left over. Okay, so then all you really got to do is your math here. So we got 5.70 times 1,000, and then obviously divide that by 2.54 cubed. So don't forget to cube that. So it's going to be 347.84. That's what the calculator gives you. And then you got to worry about how many sig figs you want to be using here. So throughout the calculations, you either did the multiplication or the division. So you want to use the lowest sig fig rule. And the original number that we have in the question is 5.70, and that got 3 significant figures. And since it has 3 sig figs, our answer should have only 3 sig figs as well. And the 3 sig figs will be made by 3, 4, and 7. So you don't want to keep anything after 7. So now whether this 7 stays 7 or becomes 8 depends on the very first number that's being dropped, which is 8. So since this is more than 5, this becomes 348. So 348 inches cubed is going to be the final answer there. All right, so hopefully that was helpful. Okay, let's look at another one. Let's try to convert 55 miles per hour to inches per second. So in this particular question, you actually have the units on the numerator and the denominator being involved. So you got to be a little bit careful, and you have to convert both of those. So in the first one, this miles needs to be converted to the inches. Okay, and we got to fill up the gap in between. And then the second is the hours needs to be converted to the seconds. So hour needs to be converted to the seconds. And if I just focus on maybe the second one first because it's easier, how many seconds are there in 1 hour? Well, 1 hour has 3,600 seconds. So if you want to go ahead and convert it to the minutes and then to the seconds, that's fine as well. But it's a common equality people uses all the time, and people have the knowledge how many seconds are there in 1 hour. So you can certainly use that as well. Now, going from the miles to the inches, well, there's a couple of things you can do. I can either convert the miles to the feet, okay, and then from the feet I can go to the inches. So 1 mile has how many feet in there? 1 mile is about 50 to 80 feet. Okay, so that's the one conversion factor you can use. And then you can also use 1 foot has how many inches? Well, 1 foot is 12 inches in there. So you got 2 conversion factors to be used in case of the miles, and only 1 conversion factor needs to be used in case of hours to seconds. If you want to go ahead and change the miles to meters and then meters to centimeters and then to the inches, that's completely okay as well. So it's just a matter of what type of equality you have in your mind or you're given. Okay, so let's go ahead and write it out now. So 55 miles per inches per hours. Okay, so let's focus on the miles. Don't focus on both of the units at a given time. Do one unit and then focus on the second unit. So I want to focus on the miles first. So in this particular case, the miles needs to be converted to the feet in the first conversion factor. So the feet goes on the top and your miles goes on the bottom. And then you know 1 mile is about 50 to 80 feet. So that's the conversion factor you want to use there. By doing so, the miles cancels out. And then in the second conversion factor, we want to go from the feet to the inches. All right. So the foot will go in the denominator and the inches will go on the numerator. And you know 1 foot is 12 inches. Okay, so by doing so, your units of feet cancels out, and now you have only inches, and that's what you're really looking for. You want to have inches on the top, and now you can focus on changing the hours into the seconds. Okay, so since I need to have the seconds in the denominator in this case, all right, and I need to have hours to be canceled out, so the hours needs to be on the numerator because that way this hour will cancel out with this hour. And then maybe I can change the colors there so this hour will cancel out with the hours here, and you know 1 hour is about 3600 seconds there. All right, and then all you really got to do is do your math here. You got 55 times 5280 times 12 and divide that by 3600. So it comes out to be roughly 968 inches per second. Well, if I go back, 55 has only two sig figs. So if I want to change 968 to 2 sig figs, how much that would be? Well, 968 is very close to 70, or another way of saying this 6 is the last digit we want to keep, and the first digit that we are dropping is 8, which is more than 5, so that's going to be 970 inches per second. So that's going to be your final answer in this particular case. All right, so if you have any questions on any of these concepts, do let me know.